Small class today. Do you have some looming deadline on the assessment? A couple. All right, fair enough. I'm not going to make that situation any better tonight. We'll go through the content. So, on the upside, it is, if you understood text files last week, the content for this week should be pretty understandable. It's basically just a different type of file access you can use. So if you have other deadlines, we won't probably use it the full 2 hours with content. Okay, so to recap what we were able to do from last week. So last week we looked at the idea of text files. And text files allowed us to open up any plain text document on our computer and read from it. We read in essentially content the way we did it. We read in each line of that document as if it were a string, but also we have the ability to write to those files. And then we saw we had the ability to append onto the files as well, so we don't have to overwrite the content. A couple of caveats for using our text files. Because we're reaching outside of our own program, we have to have a try-catch block there, just in case something's gone wrong with that file, with the location of the file, with the hard drive the file's on, whatever it might be. So having the try-catch block means that our code can theoretically encounter a catastrophic error and not crash. Now, the reality is for us as first years, we have the try-catch block in because we are forced to do it. We are not handling that error, that runtime exception, in any capacity except for saying, here's what went wrong, we're finishing now. As you go through second year, third year, fourth year, you will learn to be much more delicate, much more structured with how you handle errors and the way you can handle errors. Now, if you think about a file access issue, if the file's not there, not much your program can do if it depends on reading from that document. However, we're using the bare minimum for handling this content at the moment. So that's the first caveat. We need to have a try-catch block around our content. The second caveat that we need to remember is that when we are writing to a text file, okay, so reading from a text file is pretty simple. We're going to use our scanner. We're going to point our scanner at our file, which will allow us access in, and then we can use the stuff we're used to in scanner, next line, to read in a string at a time. But if you are writing to a text file, we use something called a print writer. And again, it's been aligned quite similarly with the idea of system.out. So we have print, println, and printf. So it allows us to push out content to that text file as if it were being pushed to the screen. But we need to remember that A, if the file does not exist when we're writing to a file, it will create the file for us. So if we have a typo in our code, and rather than class list with a space in between, if we actually have class list all one word, then it's going to create a different version of the file than maybe somewhere else in our program might use. We can also take advantage of that. If you go back and have a look at the exams from last couple of years and find the 7 divorce question, we actually take advantage of reading from one file and creating brand new files based on the content inside the original file we read from. The second thing we need to remember when we're writing to a file is if we just have print writer, well, then it's going to wipe any content that was in that file to begin with. So if we've got 1,000 records of data in there and we open up that file using a print writer, it will wipe everything in there and just start typing from fresh. If we want to be able to append onto our text, we need to add something inside our print writer called a file writer, and that will basically flip the switch from overwrite, so it wipes everything that's inside that text file, starts writing again, or append, it just goes down to the bottom and starts adding into it. Depending on what we need, we can do one or the other. It really depends on the problem we have or the issue that we have. So that's text files. Your next assignment is going to revolve around text files, so you'll have plenty of practice with it. The reality is, if you remember, you need your imports, so java.io to actually deal with files. You need your scanner for reading and your print writer for writing. You need a try-catch block whenever you actually try to access a file outside your program. You're probably going to be absolutely fine with text files because once you get the content into your program, it's string manipulation. And we've had plenty of practice in that, so I'm not worried about that. The other type of files that we might encounter are binary files. So plain text files or text files are anything that I can open up in Notepad and I can read. If I open up a TXT file, I can read that no problem. If I open up a Java file, I can read that no problem. If I open up a CSS, a HTML, a CS file, I can read all those. If I open up an RTF file, I can't. If I open up a PowerPoint file, I can't. If I open up the .class file from my compiled program, I can't really read it. Every now and again, you come across some words. Oh, I recognize that letter. I recognize that group of letters as a word. I might even recognize a sentence. But the majority of the content will come up as question marks or those empty squares, depending on what program you open up in. Those files are binary files. And binary files are a different way of writing information. Binary files usually are when you have a proprietary or third-party file system that you want to have. You want to have your files in that format. So if you've ever done any video encoding, if you have an MP4 file, it's very, very quick to extract out an MP3 file from it. So let's say you've got a film, you've recorded something on your phone, you have made a small video, and you want to just get the audio from it. That's really, really simple. And essentially what it is that the MP4 file and the MP3 file are almost the same data. One section is audio, one section is video, or the visual element of it. And there is a wrapper around the MP4 file. So this is a video file. Take section 1 and section 2, line them up so they start at the same time, and run through them this way here. If you want an MP3 file, really all you're doing is you're chopping off the bottom half of that file and saying, get rid of that. This is an audio file. And so it's very, very quick to encode. The binary file, the MP4, MP3, dictates how the ones and zeros, the data inside that file, is to be interpreted, whether it be video or to be as an audio file. And that's kind of what we're going to look at the moment. When we've been using text files, we've been using essentially characters. We're writing characters to text files. And this is 16-bit Unicode. Really handy because it makes it machine or human readable for us. And we'll see as we go through these slides, there are pluses and minuses to text files and to binary files, and we're going to discuss those as we go through. A binary file doesn't use a reader-writer collection, which is buffered. We kind of build up that scanner buffer, and we read in from it. So we open up our text file, we load the contents of that text file into our scanner, and every time we go next line, it takes the top line, it takes it out and puts it inside our program. So it's like a waiting area for the data as we load it into our program. When we use our print writer, it loads up our buffer with content to be periodically sent out to our text file. And if we're finished doing whatever we need to do to write, we do our printwriter.close, and it pushes everything that's in the buffer out to the text file. So they have these waiting areas for us. And the problem with a buffer is the time period. Have you ever been, I suppose, depending on what age and what stage in life you are, either a nightclub or a fairground, and you're waiting to either get inside the nightclub or get onto, let's say, the roller coaster. And whoever's in charge, the bouncer, guard, says, okay, next 4 people, come on. And everyone else gets to wait. So they take like a chunk. So they don't let one person in at a time. They kind of wait. If there's a big queue, they kind of go, all right, okay, 4 people have left, or the roller coaster is finished, everyone's got off it. I'll take 4, you get on that car. I'll take another 4, you get on that car. I'll take another 4, you get on that car. And so they're taking them in periods. Now, depending on when you arrive in that queue, you could be waiting very short amount of time if you just time it perfectly, or you could be waiting 10 minutes, half an hour, depending on where you are, okay? That's the idea of a buffer. It's a temporary waiting area until you're allowed in. And like a buffer, those fairground rides, nightclubs, allow in people in chunks. I'm not going to take everybody in, but I'll let you and you and you in, and that's a couple of people in at a time. A stream is how binary files are dealt with. And a stream is like that, the actual nature's version of a stream, water running, continuously flowing of information, okay? And I am live streaming this at the moment, which means that if someone were to go onto my YouTube channel now, they would start watching from this moment in time onwards, and they could dip in, watch for minute, 5 minutes, 30 seconds, whatever. It's like, oh, that's enough, and leave. And when they come back, the information would have moved on. It doesn't wait for them. Okay, so that's where a binary file looks at. A binary file supports a byte, which is an 8-bit input or output of data. When we're dealing with streams, we have 3 main streams that are involved inside Java. Oh, no blinds in these windows. Right, okay. Hopefully that's not too washed out for you. We have 3 main streams. One we've seen already, system.in. Okay, so that's our input stream. But that input stream, we have only ever used it when we've put it inside a buffer. We've put it inside system or inside our scanner. So we have a stream, and it's as if you went and you got your water bottle, you went down to the stream, and you held the water bottle in the stream until it filled up. You know, right, I've got all the information out of here. And that's what our scanner does. It fills in the information to a temporary waiting area. We have system.out, which is our print stream. It waits until I call that command, or until I've loaded up all the content there, and it pushes it out to the screen. And the last one, the one we haven't come across, is system.err. So system.err is like system.out, except it's an unbuffered stream. So if we had system.out, system.print, in our code, and something catastrophically went wrong, we actually mightn't get down to the point of printing out this message. Because there's a time period for us as humans, which seems tiny, but there's a time period we have to wait until that's actually available to send to the screen, which could be a couple of nanoseconds. With system.err, it immediately pushes out the content. Now, if it gets cut off halfway, you get half of the message, but it pushes out as much data as it can. So there are streams built into our Java language as it is. We're going to look at a different stream. We're going to look at the way of taking our content and loading it into a file, into our binary file. They're called binary files because essentially what's inside it are binary numbers, ones and zeros. So here's an example. If I were to take the integer 20 and convert it into binary, I would get this. A huge amount of zeros in the front and then 10100. Okay, so that's the binary number for 20, and then I have a whole bunch of zeros in the front. The reason why I have a whole bunch of zeros in the front is I'm dealing with a 32-bit number probably on my machine. Integers are traditionally 32-bit numbers. Okay, that's why we're restricted by our 4 gigabyte maximum range, or sorry, 4 billion maximum range of numbers, because that's the range of 32 bits. So the reason why we have all these zeros here is that's the full capacity of it. Now, the nice thing about computers is they're smart. None of these zeros mean anything. Okay? You get your paycheck, your payslip. I'm assuming you all get emailed your payslip from work. It doesn't matter how many zeros they put in front of the hundreds or the thousands on your payslip. It doesn't make any difference. It's the zeros at the back that make much more difference for however much is going to be your payslip. If we were to take a text file, okay, and we wanted to write X to a text file, it doesn't take the number 20. It takes it digit by digit and converts them to characters. Because remember, we have to convert it into a string. That's what system.out.print does. It takes whatever I put in there, string, variables, numbers, whatever, and it converts it to a string. And the way we do that is we would feed in each digit in there, and we would represent it as a character. So there is the binary code for the character 2. Not the number 2, but the character 2. And there is the binary code for the character 0. And that binary code is based off of our ASCII table. So the interesting thing is that in this example here, this takes up more space than this. All these zeros are irrelevant. They get trimmed off. We don't actually look at them. But what doesn't get trimmed off here is when you have a block of 8. Okay, so you 4 and you 4 there, you 4 and you 4 there. That doesn't get trimmed off. So the writing to a text file, the immediate advantage of binary files over text files is binary files hold data in a smaller form. If it's mixed data. If it's all string, all characters, it's no difference. Okay, but if you're dealing with numbers and with strings and with Boolean values and with other things, it can massively reduce what we have inside there. So how do we get content, which is in a binary file like this, and get it into something that's actually understandable for our code, for our program? Well, it looks a bit like this. Oh, we start the animation of that. We have our input file here. So my input file here is an input.dat. So dat for a data file. The other example you'll see, other extension you'll see me use is .bin, bin for binary. Okay. I would say, actually, do you know what? For anything I would get you from an assessment point of view, it will always be a .bin file. It will never be a dat file. The extensions are actually irrelevant. I could create a binary file that has an extension of txt. I create a text file that has an extension of bin. Doesn't make a difference at all. It's just how they're treated by the operating system. So if you create a text file, or if you go in and let's say you take, I put in this here, desktop, put it in here. No, right. Okay, there's a PDF file. That's copied up to the desktop. There's my PDF there. I can take this PDF file and I can rename it. I can actually go .txt. And it'll give me the warning, are you sure you want to change this? Yes. So if I open this up now, it'll open up in Notepad, but I don't get the data, I don't get the data out of the PDF file. A PDF is a way of encoding it. This is what I mean by a binary file. That's gibberish. I can't understand that. But there's something inside the PDF construct that will allow me to put all that content there. If you've ever worked with an editable PDF file, you can create PDF files which are locked and everything's locked down. You can't copy or paste out of it. You can create PDF files that actually you can edit the text inside them, and they can be designed that way. And that's defined by whatever content is inside here. If I were to take that file and let's say select that much and just delete it, save, close that down, and go back here and rename this again. It's a PDF. Yes, I do want to change it. Okay, so the icon changes, that's the first thing, but that's just Windows handling stuff for me. But if I open this up now, it may or may not work. Okay. So it doesn't work. What it has given me is obviously whatever information is at the very top of that file, which is, this is a PDF file with 2 pages. But the lump of text that I deleted out of it obviously is missing a massive section of the encoding of how that text is on it. Because that was an assignment for a second year. And there was 2 pages of text, a description of the program that's writing. It's all gone now because I randomly deleted some lumps out of that. So we want to make sure that when we're taking in our ones and zeros from our file, that we're taking them in the correct chunks. Okay, so the first thing I'm going to need is I'm going to need a way of connecting my binary file to some way of getting it into the program. Okay, now a binary file is a string, and we read it in as a string. However, we can't just read in ones and zeros, and there's a 1, there's a 0, there's a 1, there's a 0. That won't work for us. So we need some element of a buffer before it goes into our program. Otherwise, it'll be very hard to make sense of what it is. So we have our file input stream, which allows the connection from our file to our actual program. But we just have ones and zeros. I don't know whether that's an integer or a string or a double. Take it for you. So I need to put a shape onto it, very much like a cookie cutter. I can never pronounce that correctly. A cookie cutter. We can take this blob of ones and zeros and we can put a shape on it. And we can do that by putting a data input stream. I realize that black text on a blue background is hard to read, sorry. We can have a data input stream on that. So the data input stream is going to take whatever stream of ones and zeros I get out of this binary file, and it's going to squash a certain amount of it into a shape, into an integer, into a double, into whatever data type we're using. And then once we do that, we can read in our stream. When I know what I want to squash it into, I can take and there's my program takes it. So I can take my ones and zeros here, I can feed them in and say, oh, we'll squash that into a number. There we can see there's the number, it's a squash integer, so it's been converted from ones and zeros into an integer. And then we can actually read it into our input buffer and then put it down into our program. Okay? So that's all we actually need to do this week. It's how do we package ones and zeros into data types that we can use, or how do we strip data types into their raw ones and zeros and feed them back into a file. Beyond that, we already know how to read into a file and write out to a file to try catch that kind of structure we need to look at. So if that made sense, then you're not going to find this a challenge at all because it's going to be quite manageable. We're going to chop our way through this stuff. Okay, big problem we have is I can't open up Notepad and I can't create a binary file. Binary files are not human-made, they're machine-made. So rather than last week, when we looked at text files, we read the file first and then we looked at writing the file. We have to do it the other way around this time because we need a program to actually write the binary file for us. So here is our example. This is a very, very small example. It's actually based on what we talked about last week. It's kind of poorly written as well, but we're going to come back and we're going to revise that as we're going through it. So we need our IO import up at the top. We're going to have our try catch block there. I'm so lazy here, I haven't even put a condition in the catch block. I'm just saying, yeah, the absolute bare minimum. There's a catch there. If something goes wrong, do whatever's inside the brackets. Do nothing. We're going to have our data output stream, which is going to be a new data output stream. So that's the outer container that's going to put shape onto the ones and zeros. And inside that, we have our file output stream, which is going to be what takes, the data output stream is going to take our integer, in this example here, or our double, or whatever it might be, and it's going to peel away the outer layer just to get the ones and zeros inside it. The file output stream is what's going to start shuttling out those ones and zeros into our binary file here, b1.bin. Okay, so that connection there connects us to our binary file and allows us to take our integer value, 20, and convert that into a binary number and feed the ones and zeros in. And the way we write it out is, well, it's quite sensible. Write int, and we put the value we want to write inside there. And very much like our print writer, we have to close it. And we have to close it for the exact same reason. We want to make sure that that file is saved off and the data we've written into the file is persistent in that file. So let's actually go and do that example. Nope, that will not stay there. Okay, so okay, so here we're going to have import name. Okay, so here we're going to have our, and I'm going to change the code that was on the slide to actually make it more correct in the way we're writing it. So we're going to have our public static void main string, yes. So here I'm going to have my data output stream. Call this out file. Let's set that equal to null, which is what I should have done on the slides. I'm also going to have my integer here, int x is equal to 20. Okay, so that's pretty similar. Yes, this is a different data type here, but so far it's pretty similar to what we want to do with a text file. We would have a print writer here rather than this. Here we're going to say try. Here we're going to have catch. I'll do slightly more of an output here than we had in the previous one. So we're just going to print out the message if something goes wrong. Okay, so inside here we're going to say out file is equal to new data output stream. And so that we're going to have a new file. Output stream. And that's going to be pointed at our file, which we'll call b1.bin. And just like with our text files, the fact that I've just given the name of the file here and I haven't given any other information is telling me that wherever this file is created, it'll be the same location as my actual code. Okay? If I wanted to put it somewhere else, I'd need to have a full directory structure there, and I'm not going to bother with that at the moment. Okay, so that's going to connect me to my binary file there. And then here I'm going to have out file dot write int. I'm going to pass in my variable there x. And here I'm going to have out file dot close. Okay, so there's my program. We have our import up at the top. That's just so we can actually access our file. We have our data output stream created here, set as null initially. So if something goes wrong inside here, we actually try to connect it. Well, then we might still be able to use it lower down if it's required, depending on what the program was doing. When we get inside our try catch block, we're going to create it. We're going to say that out file is a new data output stream, which is also a new file output stream, which is pointing at the file b1.bin. Once that's all connected, it means we're actually linked to that text file or to that binary file. I'm going to call the riting method, which is going to take my integer x, strip away whatever wrapper is on it, and give me the ones and zeros inside it. And once that's written out to my file, I'm going to close my file, which will make sure that my buffer is empty and make sure that the file has been saved. And that's all our program does. So if I were to save this, go and run it. Okay, so I can see it there. Java C. Run that. Good. And Java. Okay. And if I go dir now. Okay, good. So, if you look at the very top over here, we can see we've got 2 files and 3 directories. We've got one file, which is our AO2 PDF, and we have bin filewriter.java. Okay. What happens now, once I've compiled it, is I have 4 files. I have my PDF file, I have my Java file here, I have my class file, which is the build of it, but I also have this tiny, tiny file here, b1.bin, which is 4 bytes in size, or the size of 1 integer. Okay, if I were to write 2 integers into my code, so let's just get this one here and go. Okay, again, terrible way of doing it, but let's say we've got that done there. That's 8 integers we've written there. Save the file. File run. dir. We can see now that b1, actually, sorry, it was 10 integers. We can see now that b1 is 40 bytes in size. Okay, so it's quite small, quite compact in the content that we're writing. Is that completely washed out for you guys? No, not too bad. Okay, it's just the glare coming off here. It'll be fine, let's say, in 15 minutes when the sun's dropping lower. Okay, so that's writing content to our binary file. And we'll get to the slide later on, but you can probably work out if I've got a method here called writeInt, I'd probably have a method called writeDouble, and writeCharacter, and writeBoolean. The only difference, or the only one that's hard to work out is writeString, but we'll come back to that in a moment. Okay. Now, last week, I made a comment that if you're going to be writing to text files, the modern way, the standard way of doing it at the moment is use scanner for reading into a text file and use print writer for writing out to a text file. You don't use buffered reader and you don't use buffered writer. They've been deprecated, or they're in the process of deprecation. In the same scenario, with binary files, the way we used to do it, which when you think about it is terrible, is we still use our data output stream or our data input stream and file input stream for reading in. But you know, with a text file, you'd have while our text file scanner dot has next. Is there anything left inside the scanner? And if there is, then we can read it in. What they used to do here is they had an infinite loop. So while true, which will just run and run and run and run. And when we got to the end of the file, it would actually throw an exception. And then you would handle the closing the file when it tried to crash the program. That's a terrible way of doing it. So the modern way of reading from it now is like this. For reading in from a file, we declared a variable x up here. Again, not great here because this is outside of my try catch here. That's going to cause a problem because I'm trying to connect to a file outside the try catch. But I have an data input stream, which is a new data input stream, and a file input stream. So for text files, reading from the text files, we use a scanner. Writing to the text files, we use a print writer. If you're under exam pressure and you know the usual kind of, oh, I can't remember anything, matching up scanner and print writer is, in my opinion, harder to do than data input stream, data output stream. Makes it very clear what's happening there. Okay, and again, file input stream, file output stream. So input coming into the program, output going out of the program. And we're pointing it at the same file we've just written. So we're going to read in the content from there. The way we're going to handle this now is once we get connected to our file, we're going to keep reading from the file as long as the .available method gives us a value greater than 0. .available is going to return back how many bits are left inside that text file. So as you read out the file, it's going to remove content from there. So to start off our previous example, start off at 40 bits, or 40 bytes, sorry. And then it's going to, as you read out our integers, it's going to take 4 off, so we're left at 36, another 4 off, we're left at 32, and it keep going until we have 0 left. And when we have 0 left, it means that we don't have any data left in the file. We've read the entire file. Okay, so while there's content left in the file, read an integer, print that integer out, keep going around and around, and when we're finished, when we've read the entire file, close off our data input stream, and that will allow us to release that file for other files to use. Okay, so if I take this code here, here, the file, no. Supervise it here, so hang on 1 second. Okay, so literally all I'm doing here is to find and replace to say anywhere where it says output stream from the previous example, replace it for input stream. So we have our data input stream here. Let's set that to 0 because we're reading in. Here we have, let's call this in file. Here we have our data input stream and our file input stream, again going to the same text file we just have. And here we need to change this. We say while in file dot available. It's greater than 0. So while there's content left in that file, well then I'm going to say in file dot read int. Yes, that, and then system out dot println X, sort of print out the content from there. And then here we're going to say in file program. Okay, so these aren't big examples, and there's no need to do big examples since we have spent some time with our text files. But you can see here that we have our import up at the top, or our IO. We create our data input stream here, we set it to null. Inside our try catch block, we assign the file we actually want to read from there. So we have our data input stream and we have our file input stream. When we get past line number 8, we are connected to our file. So we're going to say, while that file has any content left inside it, read the next integer, print that integer out, and that'll keep going around while the integer is left inside. At the very end, close off the file. So if I take this and I go to my command prompt, it'll print out the content that I've written. So I just wrote a whole lot of 20s out to a text file. So it's able to read in each of them. And we had 10 written out, and we're able to read back in all 10. Okay? That's a very, very basic example. We'll build on that a bit, but that's a very basic way of looking at it. So far, is everybody okay? Anybody have any questions for me at this point? No, right. Okay. So for data input streams, you can see we have very sensible methods. And as always, this isn't all of the methods for our input stream. It's the most common ones that we probably end up using. Read byte, read short, read in. So you can see what's going to happen here is that they're going to read in the content and they'll return back whatever values they have here. The one that we're having an issue with here is our strings, and our string is going to read in a UTF. Reading strings in from binary files is finicky, so we usually don't mess around with it too much. We're just going to highlight it's possible to do it. We just need to be aware of how we're going to read the content in. For our output stream, I mean, if our input stream was, our input stream is this, our output stream is just, rather than read, it's write. It's the exact same terminology. Obviously, if we're writing to a text file, we're not taking anything, or we're not sending anything back, but we are sending in the appropriate data type there. Okay, so far, everything nice and simple. I've taken 10 integers, all the same data type, and I've written into a file, and I've read back in 10 integers. What gets interesting is when we start mixing the data types. We have integers, and we have characters, and we have different variables all kind of thrown into our binary file. And as I mentioned at the beginning, that's where binary files save space, when you can have multimodal or multi-medium data in there, but not just all characters, but you've got numbers in there, you might have Boolean values, you might have different variations of numbers. That's where we can actually start saving space. So binary files are organized as a sequence of bytes. Our data input stream and our data output stream will determine how many bytes are read in or are written out as we're using them. And then they're converted into our primitive type if we're reading them in. Okay, so here is another example. So here's our data out. We're going to point our data output stream in our file here. So we're writing out, and we're going to write 3 data types. We're going to write a character, lowercase e. We're going to write an integer, minus 1358. And we're going to write a short variable, which has got a value of 5. So short is basically an integer with half its range. So rather than going up to 2 billion either side, it was up to roughly 1 billion either side. 1 billion positive, 1 billion negative. Takes up half the amount of space of an integer. A long takes up twice the amount of space of an integer, but you have a much, much bigger number range. Okay, so to write out our character, we're going to go data out, write char, and we pass in the character, just like the slide showed us previously. And what's going to happen is, there is our 2 bytes for our character. We're going to write our integer, x, okay? There's the 4 bytes for our integer. And then we're going to write our short, which is also 2 bytes. And that's going to come on there. Okay, now, that makes it look very sensible. We can see we've got nice headings here, character, integer, short. And because we know it's a character, and then an integer, and then a short, we know we read 2 blocks first, 2 bytes, then we read 4 blocks, 4 bytes, then we read 2 blocks, or 2 bytes. What if we don't have these labels here? Because we don't. In a binary file, you don't have something that breaks that down to you. So if we don't have that, it doesn't matter. Oh, sorry, if we don't have that, we need to be very careful about how we read that data in. If we read that data in as an integer first, then a character, then a short, we'll get very different values. Because what will happen is we'll read an integer in first, and we'll go 1, 2, 3, 4, chop, right? That's all an integer, and he'll convert that string of 1s and 0s into an integer, which guaranteed will not be this number here. It'll then take the next two values here and say, oh, that's your character, and convert it. Now, the problem with a character is our characters that we use are based off the ASCII table, which means we have a limit of 128 characters we can use. With 2 bytes, we can represent about 2 billion numbers. That's a much, much bigger number than 128. So more than likely, you know, when you've opened up those files and you get the weird square or the diamond with the question mark inside it, or you just get the empty square in Notepad, we're probably going to get something like that. Statistically, if you think about the range of possible numbers and what the 128 gives an actual value. And then for a short, we're actually okay because it'll use the 2 bytes to convert that into some sort of a number. So if I take that code there, actually I can make it even slightly simpler. Okay. I'm going to take my read file example here, okay? And rather than reading in integers, I'm actually going to read in doubles. And get this double here. Okay, so if I'm going to read in a double, as you'll see, where are we? Put it down. Close that one down. As you'll see from the next slide, a double is going to take up 8 bytes of data. So it'll take up 8 of those blocks. Our integer only took up 4, which means, first of all, we're only going to get 5 numbers out of reading in that file. Even though we wrote 10 integer numbers out to the file, if we read them in doubles, we only get back 5 numbers. The second issue that we're going to have is that the numbers it isn't going to be 20. It isn't going to be 20.0 for them. It'll be some other number. Okay, so let's save this. I'm in here. Compile it. Run it. Right. So we have that number there. And we're getting an error in it because we have too many decimal point digits. Well, you can see that, you can't see because the screen's offside. You can see they're all the same number. Okay, so we're taking the same 8 blocks over and over and over again. So we're basically taking 2020, whatever the binary digits for 2020 is, and we are converting that into a double. So we're getting the same value over and over again, but because it's not actually a double, it's malformed. So you can see here that we have way too many decimal points to represent properly as a double. So let's not read in a double. Let's go back in here and let's read in a float. No, let's not read in a float. Let's read in a Boolean. Okay, just a Boolean here. Okay, so now the only possible values we have are true or false. No, that wouldn't make sense, but true. And here we have a large amount of trues and falses. Okay, so that brings me back to this slide here. Most data types take in different amounts of bytes to represent themselves. You can see a byte and a Boolean are basically the same amount. A character is 2, an integer and a float are 4. Have you got to do floating point numbers with Paddy yet? Yeah, so you've seen that spec paper of why or how they've actually managed to keep decimal point numbers in it, and you understand the idea of floating point. So the bigger specificity you have on the decimal range, the lower you have in the fractional range, and vice versa. Whereas double, we're just going to go, oh no, full range on both, and that's why it's twice the size, because we have half of it preserved for integral values and half of it for fractional values. And so you can see it ranges up and down. Can anyone guess for strings why I don't have a value in there? Exactly. Until we know the length of the string, we can just take them in 2 block increments and go, there's another character, there's another character, there's another character. Okay. The next slide is more just to show you where, in the previous set of notes, in the text file notes, I used IO exception. And when I was trying to explain what exceptions are, we talked about runtime exceptions, we talked about arithmetic exceptions, we talked about index out of bounds exceptions. And you can see here in this example, I'm just using exception E. So exceptions are under a family that is a hierarchy. So if you remember your second level history, it's probably the most common place where you'd see a hierarchy, where you'd have the feudal system where you have kings and queens, and you have the hierarchy. So at the very top you have the supreme leader for that empire, and then as you go down you have who's below them and who below them and who's below them. So if you have the king at the top, well then princes and princesses are probably below that, then you have the viceroys, and then you have the dukes, and then you have, as it kind of works its way down. The lower you are down in that hierarchy, in a feudal system, the lower amount of power you have. In programming, we have the idea of hierarchies. And the way a hierarchy works is the lower you are down on that hierarchy, the more specific you are, or the smaller your domain. Kind of relates back to the feudal system. The higher you are up on the hierarchy, the more general you are, or the wider your domain, the more different types of problems in this scenario you are able to fix. So you can have a look at this slide, and then you can ignore it for the second year. This is not going to come up in any assessment for you. It's just to highlight that there are hierarchies. What that means is if I define my exceptions as just exception E, any type of problem, file not found, arithmetic error, null pointer exception, index out of bounds exception, they are all handled by that super general high-end problem. Probably means it's a really blunt solution, not really useful. If I create a end of file exception or a file not found exception, that's much more specific. So if I get an index out of bounds in my array, this can't help it. Okay, it's a different element of the hierarchy. We will look at hierarchies and how that works when we get to inheritance, when we get to second year in object-oriented design. So we'll come back to it in the first semester or second year. For the moment, I'm highlighting a hierarchy exists. For you, whichever exception you remember, go with that one. I would just go with exception E. That's, for first year, absolutely perfect. Okay, and I have one more example, and then we're done with slides, and I'll do a couple of examples, and then we'll have a look at the assignment. Okay. Oh, that coffee's horrible. So here's an example where we have a binary file. We're going to write out multiples of pi out to a binary file. So we have our data output stream here. I probably should have initialized that to null there. We have our final double pi. Okay, so the keyword final, we haven't talked about it much in first year. We don't. But just so you understand what it means, it's when you create the first value for that variable, it's locked. It can never, ever change. For a number like pi, that makes a lot of sense, because the number pi does not change. Okay, if you had class attendance, average grade, test score, something like that, you wouldn't want that to be locked as final, because it means once you set your starting value, that's it, you can never change it. So we usually set our numerical bias to 0 to begin with. That's a poor exam grade to be locked into. So we would only use final when we never want the value to be changed. We are going to connect to our output stream. So you can see here, I've moved the connection to the file inside the try-catch block. That's much better. I have my loop here, which is going to count to 100, and it's going to write out a double value of multiples of pi. So 0 by pi is 0, 1 by pi is 1 pi, 2 by pi is 2 pi, and so on. And we work our way through that, and then we have our input-output exception there, bottom. What that program should do is write the multiples of pi from 0 to 99 to a text file. It doesn't. There's a problem with that code. Can anyone see the problem? It's to do with brackets.
You're closing it before the counter.
Exactly. I'm closing it here. So that means that I open up my data file, I write one value there, I close it. I come back around again, I try to write my data, but there's no file open because it's outside the loop. It's already been closed. So this is going to crash the program after one time. We don't want that. Okay? So what we really need to do is we need to move our data out below that. We need to make sure that when you're writing out your content, your close tag is only used when you know you're finished with the text file or with the binary file, whichever file it is. Okay? If you put it inside the loop to kind of group all your file commands together, you may end up getting weird errors where the file's been locked or it's not available or the data output stream is closed, and that can obviously cause your code to work unpredictably. Fair enough? Okay, so let's have a little bit of a summary here. We've looked at text files and we've looked at binary files. The two major class of files really that you have inside a computer. Binary files are files that we cannot open up in something like Notepad and read as a human. We need another program to interpret them for us. These are basically anything, any type of file you need like a new app for on your machine. So a PowerPoint presentation, a movie file, an audio file, 3D Studio Max, a PDF file. They're all binary files. A plain text file is a file that I can open up in Notepad++ or in Notepad or something like that, and I can read all the content, no problem. So TXT files, absolutely, they're plain text. But so are our Java files, so are our HTML files, so are our CSS files. Most programming languages are plain text, and then they're built by whatever engine they are. Even if you take something really fancy like Unity or Unreal Engine for games development, while the projects might be hundreds of megabytes, if not gigabytes in size, if you remove the artwork, and they are absolutely binary files, and look at the code, they're all plain text files. You take an Android application or an iOS application, you take away the multimedia assets, so the art, the audio, any videos that might be embedded in it. It's just a series of text files built in a certain structure, and that allows the engine, whatever's building the application, to piece it together to go, oh, well, your XML file, that's the layouts, and you know where all the buttons are. And then your Objective-C file or your Java file, well, that's going to be the actual functionality, so we know what it's meant to do, and it builds it up from that. For us, there are immediate advantages for using text files. Number one, they're human readable. I can write one program to write to a text file, and I can immediately open that text file and verify with my own eyes, has that worked? I don't need another program to interpret it for me. And it also means that if I just want to create a program to read in from a text file, I can just go and I can write that file first, and then I can come back and go, oh yeah, reading that file. And again, I have verified that the content it's going to be reading in is correct. So immediately that makes them more accessible, less barriers to entry to get into them. The major problem with them is that they are quite sizable because everything is written as a character. Even if you write it as even if you read it in as an integer, when you're writing out, the print writer writes everything as a character. And so that means that the binary side of it is quite large. If I take, print out this, so here I've got my CLS, over here. Okay, so I've written 10 integers and it's 40 bytes in size in a binary file. If I take the same, here and I go new file, so import java.io.asterisk class text style. If I write the same thing as a text file, we'll see that the file sizes are different, and as we increase in our size, it varies even more. So whatever we're here, we're looking for a public select void main. So we're going to have a print writer. No. Try. This is going to be very rough and ready, but it's just to get things up and running here. So as equal to new print writer. Text.txt. Here I'm going to have out.print ln. And when I was writing it there, I wrote the number 20. So here I'm just going to have the number 20 written in. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have them all out there, and then I'm going to have out, close, catch swap. Put that in there. Right. Again, super rough and ready just to get it running here. So Java C text file, Java text file, and that will go dir. Okay, so now, well, in that example there, that didn't pan out too well for me. So you can see here that we have our binary file here being 40 bytes in size, and our text file also being 40 bytes in size. Does anyone know why? Again, it's down to the data type. Our binary file is writing integers. Each of them are 4 bytes. I'm writing 10 of them. Our text file is writing characters. I'm writing 10 characters at 2 bytes each. And each output I have, 20, is 2 characters. So 2 by 2 by 10, it also gives me 40. So if I were to change that, if I were to change the numbers, so let's go in here and run this one here, and rather than 20, 200, 2,000, 20,000, 200,000, 2 million, 20 million. Okay, right. So 20 million there is the example I'm going to use. And in this one here, I'm also going to put in 20 million for each of these. One, two, three, four, five, six, seven, eight, nine. Okay, save that one there. Go back in. Java C text file, Java text file, right, that run that one there, and then Java C bin file, right, Java bin, right. Okay, dir, right. So my bin file here, B1, is still only 40 bytes, but my text file has shot up to 110 bytes, and that's a very small example, okay? So technically the values I've written are exactly the same. But we can see that as the values increase, binary files are much more efficient at storing larger amounts of numbers. And if I were to increase that more and more, you'd see that that would balloon in size. So the immediate advantage for us is that we're able to have much smaller amounts of data, or sorry, the same amount of data in a much smaller space with binary files as opposed to text files. The disadvantage of binary files, I need another program to read them. Well, that text file there, I can go to my desktop and I can go, where's my text file? There it is there. Oh, look, there are all the values. If I get the binary file and try to do the same thing, open with Notepad. Not very helpful. Okay, very hard to work out what that is. So we need another program to interpret. You just need to be paying attention to that as you're doing it. So the advantages of text files, easy to use, quick to get up and running, don't require another program to read or to create. Binary files, they're harder to use, however, they're much smaller in space. They're much more compact to storage. A lot of the times, when it comes to running content efficiently, they either look at how fast the program can run or how small a space the program can run and store information. And this is where binary files would win. You could argue there's an element of security here, because I can't interpret that unless I know the specific sequence, integer, character, short. It's very hard for me to predict what the data is inside that. So there's an element of security, whereas again, a plain text file, it's very easy to read. I can double click it and read all the content inside that. So you could argue that, but that's tentative at best. Okay. Okay, that is binary files. Usually, when I ask a question on binary files, it's compare and contrast. I don't get you to implement binary files either in the class tests or in the exams. But I might, in question 1, which is a survey question across the whole course, I might get you to list two advantages and 2 disadvantages for text files or for binary files. And that's that kind of recap of size, space, and ease to use. Okay? That's about as far as I go from this side. Anyone have any questions? Everyone's happy enough so far? All reassuringly silent. Okay. Right. So the only other thing I want to do with you tonight is to talk about your next assignment and talk about the remaining assessment that is coming up for you guys, so you can be aware of what's on the way. Show. That should be here. Okay, right. So your assignment is up there now. Why am I trying to set up a web page? Let me go through it here so you know. So the assignment is, and I need to create the submission link for it, but the assignment is going to be issued now. It's going to be due back in week 12. Well, for ye, it's going to be due back the Monday of week 13, okay? So I'm going to give you that weekend for it. It is going to be worth 20%. It is an individual assessment, okay? So there's no group element in this. You're all working on your own for this. And what you'll be building is a Java-based dungeon adventure game. So remember, not last week, the week before last, when we built using objects, we built that very simple battle mechanism to randomly generate the attack value compared to a randomly generated defense value, and see whether an attack happened or not. We're just going to expand that into a little more of a game. So let me explain what I'm looking for. We're hitting starter code, which is on Moodle. So it's on the OneDrive already, but I've also put it up on Moodle just right beside it so you can see where it is. And we're going to create a small text-based game where you're going to battle your way to a dungeon. So not just a single monster, but you will have multiple rooms, and in each room you may have multiple monsters to work your way through. Specifically, this is looking for objects and text files, okay? So you need to make sure that your code features objects and text files. I think for ye, with Zombie Dice, you were pretty good. There wasn't a huge amount of use of things like array lists, which I wasn't assessing, and so it made it very awkward for me to actually attribute grades when people were using array lists as opposed to arrays. But just, again, to remind you, you need to have objects, you need to have text files. Your code, your game is going to have at least 2 Java files. And I'll explain what the 2 Java files are in a moment. It's going to have more if it needs, and it's going to have 2 text files. The basic Java files are going to be a person class, of which there is a starter template available on Moodle for you. This is going to be the representation of any character inside the game, either the player or any of the monsters. We will have the following attributes. You are going to have a name value, a health value, which is going to be a numerical value, an attack value, also a numerical value, and a defense value, numerical value. That's the same as what we've done so far. It's available on Moodle. But also what I want to add in there is you have the ability to hold items, up to 3 at any one time. And how you represent that is up to you. The attributes should be private, and the class should provide methods for accessing the data. Okay? Private attributes, getter and setter methods, and a constructor. Again, if you follow along with the template that's already up there, it'll be quite reasonable to get that content. The items attribute is going to represent pickups you're going to get in the game. I'll talk a little more about that in a moment. The game class is going to be the main game element. This was going to create the dungeon. It's going to populate with monsters. It's also going to handle the battle mechanic of the game, which is already written. And your goal is to randomly generate as much about the dungeon as possible. So ideally, what I'm looking for is a dungeon which is going to have a random amount of rooms. In each of those rooms, there will be a random amount of monsters. Each of those monsters will have random health, attack, and defense values. When you defeat those monsters, there is a random chance of having some sort of a pickup there to help your player as you go along. Okay, so you're trying to have it as dynamic as possible. What I would like out of this is that if I were to play the game once and play the game immediately afterwards, it's slightly different. The same universe, it's the same goal in the game, but I might have different numbers of monsters. They might be stronger, they might be weaker, different combinations. It might be a really tough game where there are no pickups at all, or it might be a really easy game where there's pickups after every single monster, but some element of randomness in there. Okay, so the dungeon. The dungeon is to be represented by a one-dimensional array of the data type of your choice. Okay, there are multiple ways of implementing this. You can go as complex as creating a room object and have an array of rooms, where the room is going to have information on it, pickups and monsters and all that stuff. You can use strings. You can even use something like an integer, where each digit is going to represent some symbolic representation of how many monsters and pickups that goes on. The length of the dungeon should be randomly generated. However, I would suggest having a menu at the beginning that would allow the user to pick easy, medium, or hard, and have ranges of rooms there. So if I pick easy, I'm going to get somewhere between 3 and 6 rooms. If I pick medium, somewhere between 7 and 11, and so on. Okay. So again, it allows for a little bit of variance within ranges. Can't be wildly random. It needs to be constrained in some way. Each slot in the array is going to represent a room in the dungeon. Each room is going to have a random number of monsters inside it, and to progress to the next room, you must defeat all of the monsters in that room. Okay? So if you were to imagine this as a game, you enter the room, there are 3 monsters in front of you, and the doors lock. And you can't get out of that room until all monsters are dead, or you're dead. Either way. Once the monsters have all been defeated, there may be an item left behind. The items can fall into 3 main categories. It can be a health pickup, literally a numerical addition to your health. So your health jumps up by 10% or by 10 points or by 25, something like that. It can be an attack pickup or a defense pickup. And what they're going to do is they're going to augment your attack or your defense for the rest of the game. They are an item that you're going to hold on to, and I'll explain how that calculation works. I think by the straw poll of raising hands, none of you have played Dungeons and Dragons? Okay, but it's going to be related kind of to that. It is also possible, if you wish, to drop a small health bonus after each monster. Because our battles are random, it's more than likely I'm going to take damage in every single turn of the game. But if I successfully get past 1 monster, maybe I get a health bonus. Maybe you put in criteria that I only get my health bonus if I perform certain actions, or if I'm able to defeat 2 monsters but only take 10 damage in total of those 2 monsters. And I'll leave that up to you to decide. Pickups are to be random. Not every monster is going to drop a pickup. Not every room is going to drop a pickup. They are chance encounters. What I would suggest is defining some way of saying how random they're going to be. Okay, so here's an example. If you have a small health boost, maybe it's a 15% chance. It's not particularly valuable, so it's a reasonably common occurrence. If you have a large health boost, maybe it's a 3 to 5%. More valuable, equates to being rarer to find it in the game. To pick up an attack item, you might get a 10% chance. To pick up a defense item, somewhere between 7 and 12. As something else, if you wish to add something to this game, make it something rare. Make it something so that if it's, I don't know, The escape button, where it automatically removes all monsters out of the room. Make that an incredibly rare item so that you can't encounter it at every room. So it has maybe a 1 to 3% chance of actually finding it if you get a pickle. Okay, does that make sense so far? Okay. The battle mechanic. The battle mechanic is exactly as we did in class, but just in case you weren't there for the class, I'm going to go over it. The battle is going to be a turn-based attack system where you are going to generate, the player always goes first. You're going to take one monster at a time. So it's nice Bruce Lee style, single file of enemies behind each other, waiting one at a time to politely go up and attack. The attack strength is going to be based on a random number. That random number will be somewhere between 0 and whatever attack value the character has. Okay, so it's possible having a 0 attack, you missed, or it's possible of having a full attack, whatever the maximum value is, or somewhere in between. Plus, any items are holding. I have a worked example to explain what that means. The defense is basically the exact same idea based off of the defense value. If the final attack value is higher than the defense value of your opponent, you have hit them. You subtract the defense away from the attack, and what's left over is the damage. And the damage gets subtracted from your opponent's health. And then it's their turn. And the exact same calculation happens. And this goes back and forth until one of you have a health less than 0. In which case, that character is dead. If it is the player, that means the game's over. If it is the monster, it means that either you move on to the next monster in that room, or you move on to the next room, or you've completed the dungeon. Okay, right. So if a player dies, the game is over. Their score should be totaled and checked against a high score table. If they qualify, their score is added to the high score table, and the new data is written to the high score. Okay, so you're going to one of your text files is going to be a high score table, and you need to check whatever your current score is at the time of completion, whether that be you died or you finished the game. Is it good enough to go onto the high score table that's going to be kept? If a monster is defeated, the player is either going to move on to the next monster, if there are other monsters left in the room, or to go on to the next room, if there are other rooms left in the dungeon. When the dungeon has been completed, the player receives an extra bonus based off of their health and how many items they've collected. Okay, so if they make it all the way to the end of the dungeon, they've defeated all of the monsters, they will have a score for doing that action, and then we're going to accrue some element of their health and maybe their items that you pick up. And I'll leave it up to you how you calculate that. So here's a very quick example. So I have two characters here. I have Owen, who's a health of 38, an attack of 11, a defense of 5. I also have a tin helmet, which gives me a +2 defense. I have a goblin, which is a health of 14, an attack of 9, a defense of 8, and the goblin has a pointy stick, which gives it an attack of 1, or a +1. So, the player's turn, I'm going to generate an attack of 9, which again is within the range of acceptance. It's 0 to 11. The goblin's going to generate a defense of 6, which again is within the range. 9 is bigger than 6, so I have hit the goblin successfully. So I'm going to subtract 6 away from 9. Gives me 3. We're going to reduce the goblin's health from 14 down to 11. Okay, that's the normal attack. That's very similar to what we did in our example 2 weeks ago. On the goblin's turn, we take into consideration our modifiers here. So the goblin generates an attack of 4, but has a pointy stick, so we add 1 onto that range. I generate a defense of 2, but I have a tin helmet, so I add 2 onto that range. So when you have, for example, if I had a tin helmet here, and my defense is 5, it's going to be somewhere between 0 and 5 plus 2. So the minimum I can generate, a minimum defense I can do here is a 2, and the maximum is a 7. Does that make sense? That is a typo because that shouldn't be 10. That's based off the attack value. It should be 38 minus 1, which gives me 37. Does the battle mechanic makes sense to everybody. Does anybody have any questions on it? Or do you want to wait until you've had time to read it and decompress it a little bit and then ask me?
Should it just go wrong? So like if you should it just go?
Yeah, I mean, it shouldn't be entirely automated, because you may have, so for example, if you've got 3 items, maybe you get the opportunity to use an item. So it might go each pair of turns. So player attacks, goblin attacks, and then maybe there's a small menu to go continue battle or use item. And the use item might be if they've got a health potion or a bag of bandages or whatever it might be, that might boost their health up. But yes, you almost automated it through. If you remember the way we did it in class, it was just kind of start and just back forward until someone's dead. This game's a little more complex, so you might have a reasoning to have gaps in there. You might also decide that no, once the battle starts, that's it, it runs until its end, and then before the next battle begins, you have the chance to use items that you have picked up. Because if I'm fighting a goblin here and I defeat this goblin, that goblin might drop 25 health, and I might want to use that before my next attack. Does that make sense? You can also, you'll see when I get down to the grading matrix, I haven't defined in any way what order you are to attack the monsters. So you could have a selection of them where it says, oh, you've got a goblin, an orc, and an elf in front of you. The goblin has health 14. So you could be kind of strategic about it. Oh, I'll get rid of the weaker ones first, or I'll get rid of the stronger ones first, hoping that they drop some bigger prize to allow you to get through the remaining ones. So you have that flexibility in the design of the game. Okay. Scoring. The score is going to be based off how much damage the player has dealt over the lifetime of the game. So when you go into the first room before your first battle, your score is 0. And as you go through that, so for example here, my score is going to go up by 3 because that's what the damage was going to be. And then the next attack goes up by a certain amount, the next attack goes up by a certain amount. So it's just a running numerical score of how you calculate that. Every time the monster is damaged, that amount should be added to the running score. The high score table should only hold the best 5 players of all time. And your high score table should be in order, in descending order. If you've ever seen an arcade cabinet, if they have a high score element in there, it starts off the high score at the top, then second highest, third highest, and works its way down. And there's usually a finite amount of space there. I'm locking you to 5, and I expect it to be in order. Okay? If you are, let's say you do a really good game, and you end up, there are already 5 scores on it, and you end up going third. 1 and 2 should stay how they are. The previous 3 should shift out to 4, the previous 4 should shift out to 5, and your score goes in at 3. And you have to figure out how to do that. The second text file I expect you to write is a log file, which will give essentially a recount of every game that's been played. So a log file will detail the room that the player has entered in, the number of monsters, and then the details of each battle. So you have dealt 3 damage. The goblin attacks and doesn't deal any damage. You use health potion, health goes up by 25. The goblin uses shiny axe and ends up doing 45 damage. So it's going to be a long, boring file to read through, but I want to see that you can create a history of what has happened inside that game. What I also would like is that a new log file is created for every game. So you need to figure out how you create a unique file name for creating that file. You're probably going to ask the player what's their name at the beginning. So that might give you some part of it. But if I play the game twice, there should be 2 different log files for each time I play the game. So you can figure out how you would do that. Okay?
Do you want the log files already there?
No,
or just
no. All I need is the Java files because I'm assuming I've newly downloaded the game I've purchased. So there's no high score yet, and there's no log files because none of the games have been played. And as I play the game, it can generate the high score table for me. If it doesn't exist, it will add to the high score table. If it does exist, it will generate a new log file for every time I play it. So I only need at minimum 2 Java files, but if you decide to create more Java files to hold that structure, then I need everything I need to actually run the program. And that's your only deliverable for this. I only need your Java files. I do not need any design. It's an individual assessment, so I don't need any assessment of your counterparts. I don't require any cover sheets. I don't require any design documents, just the Java files. I don't require the class file. Okay, so it's quite straightforward what I'm looking for here. There's the learning outcomes. The matrix of grading looks at this. So the game system itself is about 40%. That's actually working your way through the game. User interface is about 5. I've put it at 5 because when I had it at, I think it was 10 for the previous version. Some of the versions of Zombie Dice were lovely to look at, but I also feel over all of the games that I looked at, definitely some submissions probably spent more time than they should have looking for nice fancy ASCII art and less time than they should have looking at the code. And so it's just to encourage. I'm not saying me specifically because I'm talking about full-timers and part-timers, but there were some which had kind of, obviously they went ASCII art, braid, and just copied and pasted it in, great. And they had some people who tried to create almost a kind of a visual novel going through it. There was thousands and thousands of lines of text, but all it was just ASCII art. And the actual functionality of the game really wasn't there. So it's only 5%. I expect them to be descriptive. I expect to know what's happening. I expect to know who am I fighting, how much health has been dealt, how much health I have left, so I can kind of work my way through it. But I don't need a huge amount. You don't spend hours looking for ways of tidying this up. It's worth a whopping 5% in total. Text files is worth 20%. So general using of files is going to be 10%. Using the log files is going to be 4%. Using a high score file is going to be 3%. Keeping the high scores in order is going to be 3%. Coding styles worth 20%. The biggest way people are losing here is in comments. I am still getting submissions from between all the first years, full-timers and part-timers, with no identifying comment in there who wrote it. You might think that zombiedice.java is a really unique file name for your project, but it isn't. And so I need a comment in there with your name and your student number so that I can identify easily who wrote what. So 5% for indentation, pretty much everybody has that at this point. 5% for comments, ignoring the this is who I am. Comments have been pretty good, generally gone through it. 5% for use of methods. This is a big game, makes sense to break up the methods. Code hygiene is also 5%. What I mean by code hygiene is when I'm correcting assessments, I nearly always have to do some element of reformatting of your code to make it readable for me. That can be as simple as just spacing things out a little bit, so putting some white space in between it, all the way up to actually bringing everything back to column 0 and re-indenting the entire file, depending on what it is and how big the program is. It just makes it much easier for me to read, which means I'm less likely to skip something as I'm correcting it. Code hygiene comes down to how easy is your code to read, the use of your variable names, the use of your method names. Have you declared a whole load of variables and you've never used them? Are you passing in an array and returning that array as well? You don't need to return the arrays. We talked about that when we were talking about passing by reference and passing by value. If you pass in an array to get changed in some way, you don't need to return it back. It's automatically referenced back so that wherever you call it from, wherever you call that method from, it has the new updated values. So it's just paying attention to little things like that. It's only worth 5%. If I were to apply good code hygiene to the Zombie Dice assignment, most people will be somewhere between the 4 to 5 mark. Pretty much everybody's good, but I just want to start rewarding that because it's a habit that, again, it makes your code more readable, it makes you better to work in groups, to work in teams, and make you more employable when you get to that point in your career. And then the last element is I've left 15% at the end for adding something extra. The game has a lot of flexibility in there. I've given you a very, very basic outline of what I'm looking for. But there's lots of opportunity to, for example, add something like a room object. So you can hold all of the data about a room in a class by itself, and that will allow you to know what's in each room. Maybe you want to, I don't know, maybe you want to add in some pickups. Maybe you want to add in bonuses, or you want to add in negative pickups. If you've ever remember playing Bomberman and any of the iterations, there always was that one pickup which would reverse your controls, or your bombs now had half of the amount of time that they did previously. So it makes the game more challenging for a fixed period of time. You can do something like that. You can have a countdown pickup. So you have a super strong piece of armor, but it only lasts 2 battles, or only lasts 4 turns of a battle, and after that it's destroyed, and you no longer have that modifier available. So you have the flexibility to add in something. If you don't want to, it's only 15%, meaning that you have 85% available for your grade to work. That's your assignment. It is due. It will be due on Monday, April 29th. Okay, so the Monday of the last week of term. Now, just to put this in perspective, because we have now until then, that's a good chunk of time, just a little bit over 3 weeks. Next week, you have a class test with me. That will be the last bit of assessment I issue with you. Okay, after next week, you don't get anything new. You have everything to be assessed on. The class test next week is going to be the same format as the class test we had at the start of the semester. There are going to be 3 questions. There is going to be 1 question on arrays, 1 question on text files, 1 question on objects. You are to do 2 of the questions to get possibility of full marks. If you do 3 questions, I correct them all, give you your best 2 marks. It will be 1 hour in length. It will be individual. It will be pen and paper. It is to assist you in getting ready for the examination intake. Your worksheet number 2 is due for next week. I said the middle of April, so it will be due effectively for next week as well.
I think it was the 17th.
17th, did I say? Cool, grand. 17th, yeah. So where are we? April 2nd here. So next week is April 10th. No, it'll be April 9th for you guys. It's going to be class test, and then the week after that is going to be the worksheet due. As I've said since I've issued it, and it was absolutely my fault, I should have given it to you over the Christmas break and I forgot, and that's why I'm in reasonably lenient on the time on this. You have done all that content. Start getting it done, get it out of the way. Because as you can see, class test next week, and then you have this brand new assignment to work on as well. Don't do the class test and then start the worksheet, and then give yourself 1 week to do a 3-week assignment. Get stuff done and out of the way as much as possible. In relation to this assignment here, you have covered everything. As of last week, you have covered every technical element you need to finish this. There's nothing new you're waiting on for me to cover to get this done. So I would have a look at the skeleton files I put up and start thinking on how you're structured. The biggest challenge I would say for most of you is what data type you're going to use to represent your dungeon. What is that array going to be made of? It's going to be strings, it's going to be characters, it's going to be whatever it might be. Once you've got figured out, everything else should be reasonably manageable to work with. The only topic we have left to cover this year is sorting. And sorting will bring us, obviously we won't have a class next week, we'll have content next week, but sorting will bring us the 3 weeks after that. And then what I will do is I will run a class the first week in May as our revision class just prior to the examinations. Okay. Do you have any questions for me? No, okay. We have 20 minutes roughly left in this. If you want to spend that time looking at the brief for the assessment and using me as a resource to ask questions, I think that would be a pretty good idea. Or if you want to get a coffee, that's also in your remit.
Yeah.
Yeah, 1 second.